since the Grignard will not form in the presence of even mildly acidic protons, you have to protect alcohols before you can have a Grignard reaction. So if we wanted to do this reaction as a Grignard reaction and make this compound, it can't be formed because the Grignard here will react with the hydrogen and it won't form this. So the solution to this problem is to protect or block off the alcohol group. We add a protecting group, we do our Grignard reaction, and then we remove the protecting group. And the protecting group that we use is a trimethylsilane ether. And this protecting group, you can just abbreviate it OTMS. And the protected group is added using an SN2 reaction. So what happens here is I change to this oxygen is going to act as a nucleophile. It's going to attack the silicon atom, and the chlorine will then be a leaving group. Then in a separate reaction, this proton is removed. This should surprise you, right? Hera, I've just told you this is an SN2 reaction, but this is a tertiary substrate. The reason this is allowed is because this is silicon and not oxygen, not carbon. The bonds are a bit longer and the bank is open for attack, so an SN2 reaction can occur. The protecting group can be removed using acid or a fluoride ion from tetrabutyl ammonium fluoride. So this is our summary. If we want to have a Grignard reaction with this compound, we will add TMS chloride to protect the hydroxy group. Then we can proceed with our Grignard reaction. We add magnesium, and then we have our R group and then water. And the group here we add to our alpha carbon and we get our compound. It still has this protecting group on it, and we remove it with TBAF. I'm not going to say very much about the preparation of phenols. They're precursors to drugs, synthetic polymers, adhesives, antioxidants, and food additives. So they're very important, and thousands of pounds are made every year.